Yeah, I'm assuming that you're thinking that you're understanding that beauty is somehow a function of the number of symmetries or something.
No, not necessarily, no. My question was, could symmetry be a contributor to beauty? This was the first premise. You were late, that's why you missed it.
Yeah, but I heard some in the coffee break, but it was not enough, obviously.
So the question was, the idea was at the very beginning, take symmetry as a candidate for beauty, and see if I have assumptions somewhere. See if how it contributes to beauty. So, yeah, okay. So the first question was how perceptual and intellectual beauty correlate with each other, and how perceptual and mathematical properties of an entity, of a mathematical entity, contribute to judgments about beauty. So when a mathematician is saying, this is a beautiful Peterson graph, what does he mean? This was the question. And the idea was to consider symmetry as one of the properties which can be a contributor. It could be such a bright contributor to such judgments, right? And it's nice that we can visualize some mathematical objects as graphs, for example, and graphs are convenient objects in this case because on the one hand they are abstract mathematical objects, and on the other hand they have these interesting visualizations. So which means when mathematicians grasp mathematical beauty or grasp, let's say, properties of the abstract mathematical objects, they perceive it through these properties, through the visualization, right? And the question is, this visualization, it has some visible, sensible properties. So how these properties influence the judgment. And if you take symmetry also, it turned out symmetry can be visible, but it turned out there is lots of hidden symmetry, which we can't really see. We can calculate this symmetry. And the question was how this visible and invisible hidden contribute to mathematicians' aesthetic judgments compared to other people, lay people who are not mathematicians. And this was all in order to try to understand what is mathematical beauty. Is it a special kind of beauty, or is it different kind of beauty? Yeah, there is a framework, of course, there is a philosophical framework. It's just I didn't want to overload you with information, but in fact, there is a debate in philosophical aesthetics. Do we have one kind of beauty, or do we have two or many kinds of beauty? So the one kind of beauty would be perceptual beauty, and other kinds of beauty would be those intellectual, mathematical beauties. For example, in arts, we can have aesthetic evaluations of things like paintings or musical pieces, which are primarily intended to be grasped perceptually, right? And at the same time, we have literature essays, novels and essays, which are primarily intended to be grasped intellectually. Yeah? And when somebody is saying, oh, this is a beautiful novel, beautiful book, what do they mean? Of course, they read the book, but there is a physical representation of the content. Yeah? But the beauty of the novel is intellectual beauty. So, also, in case of mathematical objects, we can have similar situation. As you said, in logic, logic is symbolic. It uses symbolic. Although there are visualizations in logic, and you showed me a beautiful picture during the break, logic manipulates with symbols most of the time. And some areas of mathematics also use lots of formalism, symbolism. However, there are beautiful formulas in mathematics, there are beautiful proofs in mathematics. Yeah. I have taken the area of mathematics where we have visualizations. Yes. So I have chosen the area of mathematics closer to paintings and musical compositions, so that we can have good representatives of perceptual properties, and at the same time strong representatives of abstract properties, so that we could kind of see how they contribute to aesthetic judgments. This was my strategy. And yeah, maybe more questions.
So when we talk about the Peterson graph, we say that the classical representation is good because it depicts some of the important things about the graph, and it doesn't have a lot of visual noise. So and in the case of the Peterson graph, this gives one representation, like in some sense a unique representation. But I would assume that in most cases it doesn't give a unique representation for a graph, right? Like if I give you a random graph and as for representations that find these properties, we probably have a lot of representations.
But I'm not sure I understand. There are many representations of Peterson graph.
Yes, but you single out one that satisfies these properties of having good symmetries and not having a lot of visual noise. Okay. You see? And for a random graph, this would probably not be the case. Would probably have a lot of representations with these properties.
Okay, that's right.
So the question would be, would you expect the graphs that have this unique representation to have almost some more important role in mathematics, or would this be like
compared to the Peterson graph?
No, compared to. So if you distinguish between graphs that can have only one good representation in this aesthetic sense, and graphs that have a lot of good representations in this sense, do you think there may be like a difference in mathematical richness between them?
Well,
Is it clear?
do I think if there will be a difference in mathematical richness or mathematical beauty? Because
no, I guess both.
Well, for richness, I don't know. For richness, it could be the case that a graph, but it's hard for me to imagine that a graph has a unique drawing if it's if it's not a trivial one.
A unique, beautiful drawing in this sense. Not like a unique drawing, because that's not the case, but a unique, beautiful drawing in the sense that in the same sense as Peterson graph, there is this unique, beautiful drawing.
Well, I wouldn't say this is a unique, beautiful drawing. It's the drawing most preferable by mathematicians who work with them, because other drawings which reflect symmetries of other orders, like three-order symmetries, and they also quite nice. They look nice, but as I said, this traditional one has the maximal amount of symmetries. Maybe also I suspect that straight away you can see K5 in it. It also adds to preferences. So I think there may be many pretty, good-looking drawings of a graph. But as I said, it just turned out that when you have a maximal amount of symmetries and maximal amount of these good properties, mathematicians prefer working with it and they find it beautiful as well. No, I'm not answering the question.
Okay, so I can reformulate the question like, if you take a graph, say it has only one drawing where it has maximum amount of symmetries and minimum amount of intersections of vertices intersecting. Say that drawing of the Peterson graph has this property, and it's in some sense the unique drawing with this property.
And what is the question?
So would you expect that graphs with this kind of properties be more interesting than graphs that don't have this kind of property?
Well, a graph which would suit your characteristics could be a circle. A circle, it has only one visual representation, and it has probably maximal amount of symmetries. I mean, you can rotate. It has. It's very symmetrical in terms of rotation and reflections. Yeah, you have many angles and many axes for reflection and rotating the circle. However, this symmetry doesn't give us much of interesting properties straight away, right? And quite often mathematicians, when they are talking about highly symmetric graphs, very symmetric graphs, they mean proportions of edges, of number of vertices to symmetries. For example, Peterson graph is quite small, but it's very symmetrical. So I don't think so. I think circle is a good example. You wouldn't call it beautiful.
About the cognitive psychology experiment, yes, I found it interesting, like people prefer vertical lines than horizontal lines, or less intersections. But what this means philosophically? Because you said that beauty is not just about symmetry, but also about usefulness of the characteristics. Does this mean like that people prefer vertical lines for horizontal lines, that it's more useful to have vertical lines? How explain this psychology experiment?
Yeah, thank you very much for your question. I use this data in order to understand how the perceptual properties influence the aesthetic judgments. So it's interesting for me to understand when a mathematician is saying this is a beautiful drawing of a Peterson graph, what is he responding to? Okay, one thing, of course, it's perceptually pretty because it's symmetrical. Okay, but this data from cognitive psychology supports the hypothesis that this drawing makes it easier to grasp the mathematical structure. One can say, well, this is a practical gain. So this is not a direct contributor to aesthetic judgments. This is where philosophy comes from. And my reply is, no, it's not. These properties do not make the drawing more beautiful, but they facilitate the aesthetic judgment. When you have more noise, you don't have time, maybe you don't have energy to arrive to aesthetic judgment about the mathematical beauty of the Peterson graph. See, it keeps you, when you have more noise, the noise keeps you away from judging something as beautiful. Alright. Thank you. Good question. More questions?
I would like to mention a simple occurrence of an example which is in this book. It's from Leibniz. He didn't grasp the asymmetry of a simple polynomial, the factorization of a polynomial, and he affirmed that it was not possible to factorize in two polynomials at degree 2. But the reason under this negative of the judgment of Leibniz was that he didn't grasp the symmetry. It is in this book. It's a famous case in the history of differential calculus, 7th century. And he was a champion of grasping. No, Leibniz, but sometimes even the genius fails. The reason was the non-perception of a symmetry. And the symmetry is there. There is a little drawing here. There is a symmetry, conjugate roots of the polynomial. He didn't perceive this, the symmetry. Some little mention of the case of a great mathematician.
Well, I think it's not his fault. He noticed something else. I mean, blaming Leibniz. Leibniz is the last person to be blamed.
It's interesting to see what was the reason for the judgment, the erroneous judgment of life. It's not to appoint the error, but the reason of the perception of the symmetry, which was in fault.
Yeah, exactly. That's why mathematicians are so concerned with symmetrical drawings. Whenever it's possible to visualize symmetry, they try to do that. If other things are not in concern, like planarity, sometimes you need planarity, but most of the times they say if planarity is not the issue, try to keep it symmetrical.
I have a little example, but it's important. There is a theorem of Artin, Emil Artin, a famous mathematician, algebraist of the 20th century. In fact, he was born in 1898 and died in 1962. But the theorem is that the algebraically closed fields, for algebraically closed fields, there are only finite symmetries of order 2. It's very intriguing. And I tried hard, and I found a very beautiful proof of high school level. It's a miniature of the Galois theory in the proof, and I assess this proof as a joy. I produced this proof, and I assess this proof as a joy. I think it's a joy. My judgment.
A pleasure. Yeah?
No, a joy, no, jam.
Jewel.
Excuse me, a jam.
Não.
Like a jam.
Como é que é português?
Uma
joia.
jam.
Jewel.
Jewel. Like a jewel. It's a little proof of highly concentrated information, and the explanation is at the high school level, upgraded, of course. But it's for gifted students. We can introduce them to the concept of modern algebra and all the symmetries of fields and so on, and prove a very non-trivial theorem. Even great mathematicians, they left the theorem for the end of the great books. And sometimes with reasoning about symmetry, as I did.
Yeah. This is probably the way to introduce the students the concept of beauty as well.
Uh-huh.
There was a question over there.
Yes, it's just about this. So generally mathematicians would ask us why to do philosophy of mathematics. I want to ask, this kind of research about mathematical beauty could be useful to heuristics. For instance, George Polya's book on how to prove it, he talks about analogy, symmetry. Do you think this can be useful for a mathematical heuristic?
Yes, of course, definitely, yeah. Mathematical heuristics, yeah. And in general, very often mathematicians say that beauty is an important criteria in mathematical preferences, quite often. Yes, thank you.
Well, I think it's time for us to finish.
Thank you very much for your questions, and thank you for coming.
So
See
next time
you.
next week is holiday.
Next week is holiday, so I will see you in 2 weeks' time.
Okay.
Thank you.
Thanks.
Because everybody saw it.
É um canto que
Você está assinando?
vai descobrir, né?
Eu posso assinar.
Let him sign it.
Eu assinei a última vez.
Tudo o processo de descoberta.
Que a gente faz um
Então, a questão